Hey, D. Dykstra here, another great video for you from me about directional bearings and law of cosines and law of sines. So a lot of times when you do law of sines and cosines, what happens is we have these new directions that are given to us, and we don't look at the angles as trig angles anymore, but directional bearings that, say, a boat or a plane would fly in the real world. So let's see. Let's go back and remember. In trig, we base our direction or our angles off 0 and 90 degrees, 180 degrees, and 270, or 0, pi over 2, pi, and 3 pi over 2. In bearings, they base everything off north and south and east and west, and we'll often see times where we'll call north 0 degrees as we work around to east, that's 90, and south 180, and west 270 degrees. So it works around this way, get up to 360 again. Now there are different ways to call bearings, and we'll see some different situations where maybe we're looking at a northerly direction or a westerly direction. So let's see. Some information we might want to know. Our bearings are based on the direction of north and south. Okay? North and south. And what degree to the east or west. So, if we look at a few examples here, we can see that point A here is 45 degrees from north. So we would call that north 45 degrees east. So we start at north, we're going 45 degrees in the easterly direction. Alright? If we want to look at down here, if we could say, oh, this is point B, right? Point B. Then we might say, well, point B, if we go from the south, then we would go, well, that's 70 degrees up from the south. 70 degrees up from the south, so that's south 70 degrees east. Okay, so that's one way to write it. Now, we also might be able to write that coming from north and heading in this direction. So if I'm heading this direction from north, now I'm going past 90 degrees. In fact, I'm going 20 degrees past 90 degrees, so we would call that north 110 degrees east. Same thing is true for the other side if we're dealing with west. Okay, if I look at this purple one, then I have over here, this is 80 degrees from north, and so, but it's in the westerly direction, so we'll call that north 80 degrees west, starting at north and going in the westerly direction. All right, well, hopefully that helps. So we're going to look at a problem, and first we have to sketch the drawing, and then we're going to solve it to find some things out. It says, sketch the flight path of a plane. The plane takes off from point A on a bearing of north 30 degrees east. It flies 200 miles to point B, and then at point B, the plane changes course of a bearing of south 40 degrees east for 300 miles to point C, its final destination. All right, so now what we want to do is we draw that. So we start off and we make a little crosshair, right? North, south, east, west. If we wanted to label that, we would say, again, this is north, south, east, and west. And so if we want to say north 30 degrees east, then that's going to be that little corner right up there, that little angle, because it's 30 degrees east of north. So 30 degrees. And it flies for 200 miles. So I label that 200 miles. Till it gets to point B. Now point B, it says the plane changes course on a bearing of south 40 degrees east. So then if I go from the south, here's south, and east, it goes 40 degrees east of south. So then I am here, south 40 degrees east, and it heads there for 300 miles. Till it finally hits C. Alright, so it looks like we've drawn that pretty close to what it might be. Now, it's not scale, obviously, so let's look at what the next part says. The next part says, Find the distance from A to C and the bearing from C to A. So A to C, the distance here, and then the bearing if I'm taking off from C and I got to go back home to A. Well, as you can see, this is a law of cosines. We have two adjacent sides and the inscribed angle. So, this inscribed angle, we know from before that if this was 30 degrees, then if we use alternate interior angles, you recall alternate interior angles, we have two parallel lines, and this angle here and the opposite interior angle will be congruent. So angle 1 is congruent to angle 2. So we have the same principle here. If this is 30 degrees, then I know this is 30 degrees, okay, off the horizon. So here I am. Hey, look. Okay, so now that's 30 degrees. So then we know if that's because this angle here would be congruent with that angle. So that is that angle. So that is also 30 degrees. And 30 plus 40 makes 70 total degrees. So what I can do is I can then call all of this 70 degrees. Okay, 70 degrees. Now, for law of cosines, we need two sides and the inclusive angle. So once I do that, then I can find the distance from C to A, or A to C, is the square root of, if you recall the law of cosines, it's C squared is equal to A squared plus B squared minus 2AC cosine of the opposite angle of B. All right? So we have 200 squared plus 300 squared minus 2 times 200 times 300 times the cosine of 70. And when you do that, you get 298.3 miles. So pretty close to 300 miles, almost the same distance. Now, what I want to do is, so that's the distance from A to C, 298.3 miles. The next thing it says, find the bearing from C to A. So when this plane takes off, what is the bearing? Now again, this drawing is not necessarily to scale, but we should notice that this is up a little bit higher, so we're going to fly in this general direction there. So it would be helpful if I had this angle, because if I know that angle and I know this angle is 40 from the same thing we had here, which was the alternate interior angles congruency. If I have that angle, then I can add those two angles together and I will get the bearing from north. Okay? So, I take the sine of 70, right? There's my 70 for law of sines. I need an angle and a side, and its opposite side, and a side and its opposite angle that I'm looking for. So sine of 70 over 298.3 is equal to sine of C over 200. And then cross multiply the 200, we get 200 sine 70 over 298.3. And I take the inverse sine of that, and I get C is equal to 39.05 degrees. I add that to my 40 degrees here, because now I know that this is 39.05. I add that to my 40 degrees, and I get 79.05. So the bearing then is north 79. If we wanted to round to the nearest tenth, we could. We could call it 79.05, but 79.1 in the westerly direction. And that is the bearing that the plane would have to fly in order to get back to A. Okay? Anyway, I hope you found that useful. Again, go back, replay it, check it out. These bearing problems aren't necessarily difficult, but it does require some memory of the corollaries and other rules that you learned in geometry. All right? Thanks again. D. Dykstra, out. Peace.